I want to continue about ionic radius. So the basic of ionic radius is we look at electron. So both electron has negative charge. So when both electron have negative charge, it will repel each other. This concept should be applied in the atom. So I give you one example of sodium atom. So sodium atom has 11 protons and 11 electrons. Yes. So this is the sodium atom has 11 protons and 11 electrons. For sodium ion, it has 11 protons but it has 10 ions, 10 electrons. So if we look at over here, it has more electrons. If there are more electrons over here, then the electrons will repel each other, making the atomic size bigger. Thus, for this, the atomic size is smaller for the sodium ion because there are less electrons. I will show you about group period 2 going to the right. So from the left is carbon, nitrogen, oxygen and fluorine. As we can see, the atomic size of this to the right gets smaller. So this is the explanation. Let us see nitrogen and oxygen. So nitrogen has 7 protons and oxygen has 8 protons. So let us draw. This is the nucleus, this is the atom, this is the electron, and this is the valence electron. So the effective nucleus energy, how do we get the effective nucleus energy? So by looking at this atom. So the nucleus is +7 and the electron covering the nucleus is 2 to the valence electron. So it means 7 minus 2 electrons equals to +5. So the effective nucleus energy is +5. So for oxygen, let us see. Oxygen has 8 protons. So let us draw. So this has 8 protons. So the valence electron is 1, 2, 3, 4, 5, 6, 6. The nucleus. So how do we get the effective nucleus energy? 8 minus 2 is equals to 6, +6. So here is +5 and here is +6. Because there are more protons in oxygen than in nitrogen. So the electrons are the effective nucleus are equal. Okay, as you can see, this is +6 and +5. So the electrons here is more attracted to the protons than over here, than in the nitrogen. So the size and the atomic size gets smaller. So it is the same as this concept. Yeah. So today I will discuss about variation in atomic and ionic radius down a group. Alright, students, down a group. Okay, attention. Okay, so we talk about variation in atomic and ionic radius down a group. So I'll give you some example: hydrogen, lithium, and yttrium. Okay, as we know, hydrogen contains one electron only. So one s, one electron. So we make the orbital is 1. And second, the lithium. The lithium contains 3 electrons. So we have 1 shell and 2 shells. It contains 2 shells. 1 electron, 2 electron, and 3 electron. Okay, next is natrium. Natrium contains 3 orbitals and contains 11 electrons. 2, 4, 6, 8, 10, and 1. Sum it up, it contains 11 electrons. So I will explain to you about why it came. Okay, so as we know, these 2 electrons here is in the first shell, in the inner shells. 1, 2, and this 2s, 2p contains 2, 4, 6, 8 electrons. So it is included in the second shells in 8 electrons. So and the last one is 2s, it's containing 1 electron. As you all know, the electron at the outer nucleus and outer shells wants to get closer to the nucleus, but initiated by 2 shells, the second shells and the first shells. So first, the inner shells. This is a conclusion from what I explained before. Okay, the first one, the inner shells shield the outer electron from the nucleus. Well, what this means that this inner shells shield the outer electron, from getting nearer to the nucleus. Okay, for the second one, they are held less tightly, resulting a larger radius. So why it is held less tightly? So here, this is electron, and it's getting nearer to the nucleus, but it's shielded by 2 shell, and it resulting less tightly and resulting a larger radius. Okay, and for the third one, radius increase going down the column because of why? Because due to shielding. This shielding, when the shell increase, this means the radius of the nucleus, the radius of this element, so increase.